25% of its volume beneath the water. I did not take this problem from Steve Cam when we were just talking about the duck in class. But we have a duck now with 25% of its volume beneath the water. We want to find the average density of the duck. Okay. Here's my duck. You can draw your ducks better than that, but my duck is a box here with 25% of its volume below the surface. Okay. This amount here is 25% of the duck's volume. That's what was given in the problem statement here. Okay. We want to find the average density of that duck. Let's assume it's freshwater. Okay, so the density here is 1,000 again kilograms per cubic meter. How are we going to find the density of the duck? It's not in the table, so we can't just look it up. Could we do the mass over the volume to find the density? If we knew the mass of the duck, if we knew its volume, but we don't here. Okay, something's floating. What's making it float? The buoyancy force, right? If there's a force acting on something, you draw that free body diagram. Always start there. Okay. Let's do that again here. Free body diagram has now the weight going down. What else? Going straight up. Anything else? That's it. Okay. Sum of the forces in the y direction equal to mass times acceleration, like always there. Our a is 0. Again, we're at rest here. This is just FB minus mg is equal to 0. Or the buoyant force is equal to mg. Those two things are going to be equal if something's just sitting there afloat here in some fluid. Before we were keeping it submerged or holding it up. There were other forces there. Here there's just two. These two are the same. Don't ever just start by saying the buoyant force is equal to mg though. In a case like this, maybe you could do that. But in general, draw your free body diagram and prove to yourself why it is just that. The last problem we had 3 forces. Okay? They won't always be like this. Okay? But once we're down here, let's just write it out again. Which mass is this? The mass of the water or the mass of the duck? That's the mass of the duck. That's representing this force right here. Let's put an md times g there. What's the buoyant force? Or another way to write the buoyant force in general? The density of the fluid times gravity times the volume of the fluid displaced. Okay? So I just put it all in there with F's. Because we don't know the mass of the duck, then maybe we should rewrite this as the density of what? Which density now?
The water.
This is the density of the duck. Because for the mass of the duck, it depends on its own density times the volume of the duck. Let me call you the volume of the duck, VD there. Everybody see that? Just density times volume. Over here, well, we'll just leave these as rho F, G, and VF now. Okay. What can we do with the G's? Those divide out here. What about those V's? Are they the same? They're not the same. Which one of those can I rewrite another way?
Volume of the duck.
The volume of the duck.
25% of the volume of the fluid. Isn't that right?
The volume of the duck is more than the volume of the fluid. The volume of the
Or
fluid.
yeah, the volume of the fluid is 0.25 VD.
Yes, so this here, the volume of the fluid displaced, that piece right there is equal to 25% of the volume of the duck. So this would be 0.25 times VD there. Okay. So yeah, I can rewrite that now. The density of the fluid times 0.25 duct is the density of the duct times the volume. Okay. Look at this line up here though. We have rho GB and we have rho VG again. If you're not clear with your subscripts, you'll cancel things out that should not cancel out. Make sure you're very, very clear. The math isn't that long or that hard in terms of that there's no sines or cosines, there's not a bunch of terms with vector components, but it's just the notation here that will throw you off sometimes. We can solve this now for the density of the duct. Just divide out the V's. This is 25% of the density of the fluid. So 25% of 1,000 is 250 here, kilograms per cubic meter for the density of the duct. You really have to be clear on when you need to write, this volume of the fluid as some fraction or some percentage of the total volume, or when you can use it as the total volume like we did last time when it was completely submerged. You really need to take time to understand where these are. This is not an equation where you can just take numbers and plug them right in. There's a lot of mistakes there with that, where people just maybe know the equation but don't know really how to apply it. Okay. Any questions about any of the steps in here? I think in this case down here we couldn't get the mass separately like we could before. Here's a case where we actually had to really put it in here. There was no other way to do this for me to write this out that way. These all start, for me, with a free body diagram. You just need to start there, and when you have that volume force, you put it in like that and figure out what that density should be, what that volume should be. But where you have trouble sometimes is just relating the masses to densities and volumes, figuring out what this statement is right here about the percentage that was in the water. Those are all the places where they sometimes get tricky. Okay? You can definitely do them. It's just, this is just a topic that I usually see. It takes people a little bit longer to catch on to it, just because of the notation and the different things in there. Okay? I'm going to give you an in-class assignment over in lab before you do the experiment. I'll give you one more practice on that. This one here at the end, we're going to come back and do it at the beginning next time. I want to kind of just wait and do one more at the beginning, give you a couple days to think about it some more, and then we'll come back and do another one where we're going to have a raft that's made of some logs that are all lashed together, and we want to figure out how many people can fit on that raft without it sinking. So we'll do that next time. Try to start looking at the homework, try to start thinking about these problems from today, from lab, and then we'll come in at the beginning next time and hopefully you remember some things. Okay?